Good morning, everyone. We are the group 4. I am Geraldine Ansitukaw, and this is laboratory activity number 12, reactions of carboxylic acids. Specific learning objectives. At the end of the experiment, the students shall be able to describe the acidity and solubility of carboxylic acids, determine the effects of oxidizing agents on the carboxyl group, and identify the other reactions of carboxylic acid. Learning strategies. One of the important properties of carboxylic acid is the reaction of the ionizable hydrogen. Carboxylic acids reacts with water as follows. Example. The equation indicates that the reaction does not proceed appreciably to the right and that most carboxylic acids are therefore weak acids. If the acid has been substituted by the electron-attracting group or element on the alpha carbon, like chloroacetic acid CH2ClCOOH, its strength as an acid is markedly increased. Carboxylic acids reacts with the base to form alkali salts, which generally are soluble in water. This reaction is possible because of the acidity of the carboxyl group. Example. A number of reactions of carboxylic acids involves the replacement of hydroxyl group in the COOH. One of these is the reaction of alcohols. The replacement of OH by the OR group or the alcohol leads to the formation of esters. These reactions is often acid catalyzed. Example. The formation of ester is usually detected by the evolution of pleasant odor. Carboxylic acids are relatively resistant to oxidation. However, some acids like hydroxy acids and other multifunctional acids may be oxidized. Next reporter.
Good morning, everyone. This is the laboratory number 12, reactions of carboxylic acids. For the data and results of the acidity and structure, one of the given carboxylic acid is acetic acid. And this is the structural formula of the acetic acid. And it has a pH of 2.4. Another one is monochloroacetic acid. The structural formula is this, and a pH of 2.87. The last one given from the carboxylic acid is trichloroacetic acid. This is the structural formula and a pH of 1.2. From the question below, what is the effect of Cl on the acidity of the carboxylic acids? The presence of the chlorine atoms clearly increases the acidity of the carboxylic acid group because the presence of such groups near the COOH group of a carboxylic acid often has an effect on acidity. In general, electron-withdrawing groups increase acidity by increasing the stability of the carboxylate ion. That's all. Next reporter, please. Thank you.
Good morning, ma'am. Good morning, classmates. Letter B, solubility and water, and in 10% NaHCO3, acid sample. Acetic acid structural formula. Solubility and water infinitely miscible. Solubility and 10% NaHCO3. Acetic acid solution more than 10% but not more than 80% acid appears as a colorless aqueous solution. Benzoic acid structural formula. Solubility and water purely soluble in water. Solubility and 10% NaHCO3 is also a strong acid, therefore it will dissolve in sodium bicarbonate solution to form salt and water by liberating carbon dioxide. Oxalic acid structural formula: solubility in water, slightly soluble in water. Solubility in 10% NaHCO3. It is a colorless hygroscopic crystalline solid with a snow-like aspect. It is soluble in water 143 gallon liter at 25 degrees Celsius. More soluble in ethanol 240 gallon liter but purely soluble in either 18 gallon liter. Succinic acid structural formula: solubility and water, water acetone, solubility and 10% NaHCO3. Since carboxylate ions have a negative charge, they are more soluble than carboxylic acids, readily dissolved in sodium bicarbonate solution. Dipic acid structural formula: solubility and water, alcohol acetone, solubility and 10% NaHCO3, soluble in methanol, ethanol, ethyl acetate, acetone, slightly soluble in water, cyclohexene. Explain the effect of structure on solubility. Explain also the difference in solubility in water and in NaHCO3 solution. Positive is attractive to negative, making a cohesive structure. When polar compounds or ions are added to water, they break up into smaller components or dissolve to become part of the solution. The water's partial charges attract different parts of the compound, making them soluble in water. Solubility is the ability of a solid, liquid, or gaseous chemical substance referred to as the solute and form a solution. The solubility of a substance fundamentally depends on the solvent used as well as temperature and pressure. The solubility of a substance in a particular solvent is measured by the concentration of the saturated solution. A solution is considered saturated when adding additional solute no longer increases the concentration of the solution. The degree of solubility ranges widely depending on the substances, from infinitely soluble fully miscible, just as ethanol in water, to purely soluble, just as silver chloride and water. The term insoluble is often applied to purely soluble compounds. Under certain conditions, the equilibrium solubility can be exceeded, yielding a supersaturated solution.
Good morning, everyone. So now let's proceed to ester formation. Esters are formed when the carboxylic acid is heated with the alcohol in the presence of a catalyst. In this reaction, the concentrated sulfuric acid is used as a catalyst. Dry form of hydrogen chloride gas is used in some cases. This method of reaction is used to convert alcohols into an ester. First procedure is ATOH plus acetic acid plus sulfuric acid. Observation: ethyl acetate is commonly synthesized by the reaction of ethanol and acetic acid via the classic Fischer esterification process. As a chemical reagent, ethyl acetate is always used in glues, decontaminants, and oil removers. In addition, for the low cost, low toxicity, and agreeable odor, ethyl acetate is mainly used as a solvent or diluent. In detail, a mixture containing ethyl acetate is always used as elution liquid for column chromatography and extraction in the laboratory. Moreover, it is also used in paints as an activator or hardener. Ethyl acetate is an important organic compound which has a special sweet smell. This is the illustration for the chemical equation of the first procedure. The second procedure is MEtOH plus salicylic acid plus sulfuric acid. Observation: Methyl salicylate is used topically as a counter-irritant. When applied topically, sufficient methyl salicylate is absorbed to provide pain reliever for those suffering with rheumatic conditions, painful muscles, or joints. Esterases in the skin rapidly hydrolyze salicylate esters to the active salicylic acid in both the epidermis and dermis layer of the skin. Methyl salicylate or oil of wintergreen is a chemical that smells like wintergreen. So this is the illustration of the chemical equation on the second procedure. Give the names and structure of the ester for the above reaction. For the first reaction, ETOH plus acetic acid plus sulfuric acid, its name is ethyl acetate. This is the structure of ethyl acetate. The transformation of bioethanol to ethyl acetate mainly bases on the catalytic dehydration of ethanol, and the copper-based catalyst is the major catalyst type used for the conversion of ethanol to ethyl acetate. During the conversion of bioethanol to acetaldehyde and acetic acid, ethyl acetate acts as a byproduct after the reaction, which indicate that it is feasible way to transform bioethanol to ethyl acetate based on a special catalyst and under suitable conditions. The second reaction is MEtOH plus salicylic acid plus sulfuric acid. Its name is methyl salicylate, and the structure for methyl salicylate is this. Methyl salicylate is an ester salicylic acid derivative found in many plants. Wintergreen Gaultheria procumbens is one of the species with the highest concentration of this compound, and therefore this molecule is known as Gaultheria essential oil. It can be used as an additive in food because it has a flavor similar to mint. Next reporter, please. Thank you.
I am Hanin Salik, carboxylic acid, formic acid. This is the structural formula. Observation when heated. Formic acid decomposes to carbon monoxide and water dehydration when exposed to heat and acids. Treatment of formic acid with sulfuric acid is a handy laboratory source. Observation after heating. We found that mild heating can cause the thermal breakdown of formic acid to under electrochemically relevant circumstances. Acetic acid, and this is the structural formula. Acetic acid decomposes at temperatures above 440 degrees Celsius to produce carbon dioxide and methane or methane and water. A typical condition, the enthalpy of liquid formation, the propionic acid, and this is the structural formula. Esterification occurs when propionic acid is heated with methanol in the presence of a few drops of strong sulfuric acid, resulting in the formation of an ester methyl proponate and water. Several bacteria belongs to the genus Propionibacterium, including the species Clostridium propionic, perform propionic acid fermentation. Lactic acid. This is the structural formula. When heated to temperature of around 180 degrees Celsius, lactic acid produced during fermentation is prone to the formation of color bodies. When heated to temperature of around 180 degrees Celsius, lactic acid producing during fermentation is prone to the formation of color bodies and higher. Tartaric acid. This is the structural formula. Tartaric acid has a milder, crisper flavor than tartaric acid. Although it most commonly associated with grapes, it can also be found in the pineapple, strawberries, mangoes, and citrus fruits. Calcium carbonate scale development is a major issue in many industrial operations, including chemical, desalination, and oil industries. Citric acid, and this is the structural formula. Citric acid chemical structure is similar to that of other carboxylic acid. It decomposes when heated over 175 degrees Celsius, releasing carbon dioxide and water. The amount of citric acid in milk and how heat affects its acid was studied with the intention of comparing the outcomes. Scurvy or Barlow's illness is said to be caused by infants fed hot milk. Benzoic acid. In certain series of measurement, the mean absolute heat of combustion of benzoic acid under conventional bomb circumstances. To determine the calorimeter heat capacity, we first burn a precisely weighed mass of a reference chemical whose enthalpy of combustion is known. Oxalic acid. As a result of heating oxalic acid in the presence of concentrated sulfuric acid, carbon monoxide or carbon dioxide and a water molecule are produced. When the flask is hot enough, you may observe vapor flowing out of flask neck and condensing. Succinic acid. This is the structural formula. The structure of succinic acid is plainly evident as a structure with a dipole moment. Succinic acid is a widely used chemical in a variety of industries. Water control. This is the structural formula. When you heat water, the water molecules begin to move around quickly. They bounce off one another and grow apart because there is a greater space between the molecules. When heat is delivered to water for the first time, the intermolecular hydrogen bonds inside the sample must be broken. And that's all po. Thank you.
Give the possible inference based on the difference in structures. An acid is a molecule or substance that has a pH value less than 7 in an aqueous solution. When dissolved in water, an acid raises the concentration of the hydrogen ions.
Let us go on to Tulens reagent. Tulens reagent is a chemical reagent used to distinguish between aldehydes and ketones, along with some alpha hydroxy ketones which can tautomerize into aldehydes. So there are two instances in the procedure: the Tulens reagent plus formic acid and Tulens reagent plus oxalic acid. As a result, with Tulens reagent plus formic acid, the observation is that formic acid is a reducing agent because it comprises both aldehyde and carboxyl group. Tulens reagent is reduced to metallic silver by using formic acid. Next is Tulens reagent plus oxalic acid. As a result in the observation, oxalic acid does not oxidize because it solely has the carboxylic acid group. Aldehyde and Tulens tests undergo oxidation and create matching carboxylic acid. And since it is a weak oxidizing agent, it cannot oxidize ketones. Hence, the possible conclusion are: the Tulens test is done with formic acid instead of acetic acid. Tulens reagent is an ammoniacal silver nitrate solution. When formic acid is heated with Tulens reagent, a silver mirror forms on the inner surface of the test tube.
Mechanism for the preparation of methyl salicylic. Place 0.65 grams salicylic acid, 10 ml methanol, and a magnetic stir bag in a round bottom flask. Stir the mixture until the salicylic acid dissolves. Place the conical flask on a stirring hot plate, and while stirring slowly and in small portion, add 0.75 of concentrated sulfuric acid to the salicylic acid methanol solution. Attach the round flask to the water-cooled condenser. Cap the condenser with a drying tube that has been loosely packed with calcium chloride. Gently boil the solution for 75 minutes. Maintain the temperature at approximately 100 Celsius. The reflux will allow the mixture to heat without loss of components. Through evaporation, the vertical condenser returns the evaporated liquid to the boiling flask. In this reaction, the reactant undergo a transesterification, which is when an ester reacts with an alcohol to form a new ester. Shake the resulting suspension. While venting, allow the layer to separate and transfer the organic layer, which contains your product, to another container. Mix the solution together. Allow the solvent to separate and transfer the organic layer to a clean, dry flask. Dry the solution with anhydrous sodium sulfate. Mechanism for the preparation of ethyl acetate. Ethyl acetate is traditionally synthesized from by heating ethanol with ethanoic acid in the presence of a catalytic amount of a strong acid such as sulfuric acid, the Fischer method. The equilibrium lies slightly on the ester side. Yields can be improved by removing water as a esterific mixture with benzene or dyeing agent like molecular salts, or by the use of excess alcohol. Application of Le-Chatterley's principle. Other results include the reaction of acetyl chloride, ethanol chloride with ethanol.
In a nutshell, a carboxylic acid's acidity is higher than alcohols or even phenols. Carboxylic acids are weaker than mineral acids, yet they are the most powerful among organic molecules. They are soluble in all organic solvents, but low molecular mass species are only soluble in water. Further oxidation eliminates the carboxyl carbon as carbon dioxide because it is already in a high oxidation state. The oxidation state of the residual organic structure may be higher, lower, or unchanged depending on the reaction conditions. Carboxylic acids undergo reactions that result in derivatives. Esters, acid halides, acid anhydrides, and amides are the most common derivatives generated. Furthermore, carboxylic acids have a significant role in biology. Some people are sensitive to the acidity of aspirin, which is a carboxylic acid. Ibuprofen, a non-aspirin pain medication, is likewise a carboxylic acid. Lastly, fatty acids are carboxylic acids also.